Hello, in this lecture we'll find out the value of x. In the drawing we have a quarter circle, EFE is a quarter circle. Inside this quarter circle we have this square ABCD. In addition we know that this is 97 DE. This is equals to 12 units in its length. And this is angle GDC, this is equal to theta, and this is angle EDC, this is also equals to theta. Again, our mission was to find out the length of this line segment GD, that is equal to x. We have to find out the value of x. So, first of all, we know that all the angles inside square ABCD are right angles, so those four angles, they're all right angles. So, this angle equals to 90 degrees in its size. This angle is also a right angle. This angle equals to 90 degrees in its size. And this angle is also a right angle. In addition, we know that the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to the opposite side AB. So I write it down. In square ABCD, side DC is parallel to side AB. But here AB is part of the straight line AE. Again, AB is part of the straight line AE and is parallel to DC. And you know that if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. And therefore, the straight line AE itself must be also parallel to DC. So here, AE is also parallel to DC. Okay. So here we can implement rule 15. According to rule 15, alternating angles between parallel lines are equal to each other. So in the drawing we have line A is parallel to line B, and those two angles alpha and beta, they are defined as alternating angles. And because of the fact that those two alternating angles are located between the parallel lines A and B, they are equal to each other. That is to say, alpha equals to beta. So whenever you have two alternating angles that are located between two parallel lines, they must be equal to each other. In this case, alpha equals to beta. So actually we can implement rule 15 in our drawing. Why? Because in our drawing we have line AE is parallel to line DC, and those two angles are defined as alternating angles, and they are located between the parallel lines AE and DC, and therefore they are equal to each other. So those two angles are equal to each other. So this is angle EDC. And it is equal to this angle, that is actually angle AED. So angle EDC equals to angle AED according to rule 15. But this is angle EDC that is equal to theta according to what is given as the question. So can I tell that angle EDC equals to theta? from this equation, theta equals to angle EDC equals to angle AED, we will derive that angle AED also equals to theta. So angle AED is also equals to theta. So this is angle AED, that is equals to theta. Okay. So in the next step, we'll do a construction. That is to say, from point G, we'll do perpendicular on AB. Again, from point G, we'll do perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point between perpendicular GN and side DC of square ABCD as M. By doing this construction, we get quadrilateral DMAN or DMNA. This is quadrilateral DMNA. Inside this quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. 270 degrees plus 90 degrees, it is 360 degrees. That is the sum of the angles in any quadrilateral. So inside quadrilateral DMAN, we have 4 right angles. And we know that any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral DMAN as a rectangle, because it has 4 right angles. GN is perpendicular on AB, therefore GN is a perpendicular, it is absolutely a straight line. GN is a straight line, so if you focus on the left side of the straight line GN at point M here the sum of the angles must be equal to 180 degrees according to rule 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is a right angle plus this missing angle. In total, the sum of those 2 angles must be equal to 180 degrees. Therefore, this missing angle GMD, the missing angle GMD must be equal to 90 degrees in its size. And therefore, triangle GMD, the small triangle GMD, is a right angle. So I copy this small right angle GMD in a new page, and we analyze this right angle, triangle GMD. the hypotenuse GD of the right triangle GMD is equals to x according to what is given as the question. So actually, this is the right triangle GMD, the copy from the original drawing. In this right triangle GMD, it is very easy to see that cosine theta equals to dm over dg. Again, cosine theta equals to dm over dg. So write it down. Cosine theta equals to dm over dg. dm is the missing side, so we leave it as it is. Over dg. dg equals to x according to what is given as the question, so we substitute dg by x. So in conclusion, according to equation 1, we should find out that cosine theta equals to dm over x. So here we multiply this equation 1 by x, and finally get that according to equation 1, dm equals to x times cosine theta. Again, according to equation 1, dm equals to x times cosine theta. In the next step, we will define one side of this square ABCD is y. Therefore, all the four sides of this square ABCD, they are equal to y. AD equals to y. AB equals to y. Side CB equals to y. And finally, side DC is also equals to y. So what is the definition of line segment AE? Line segment AE starts from point A, that is the center of the quarter circle, and then at point E, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. We define the radius of this quarter circle as r. Therefore, AE equals to r. So now I'll copy the right triangle ADE in a new page, and we will analyze this right triangle ADE. The hypotenuse DE of the right triangle AD equals to 12 units in its length according to what is given as the question. So actually, this is the right triangle ADE, the copy from the original drawing. In this right triangle ADE, it is very easy to see that cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. So according to this equation, equation 2, we actually found out that cosine theta equals to R over 12. This is according to equation 2, but we have already found out that according to equation 1, dm equals to x times cosine theta. So here we have two equations. Here we can substitute cosine theta in this equation, equation 1, by r over 12 for this equation, equation 2. Because cosine theta equals to r over 12 according to equation 2. We'll do it now, and finally we get that dm equals to x times cosine theta. And cosine theta is r over 12. So in total, dm equals to xr over 12. dm equals to xr over 12. So this is side dm, and it is equals to xr over 12. We have already found out that quadrilateral DMNA is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMNA, side DM equals to side AN. Side DM equals to side AN, but side DM equals to XR over 12, therefore side AN must be, the opposite side AN must be also equal to XR over 12. Likewise, according to the same rule, in the same rectangle DMNA, side DA equals to side MN. Side DA equals to the opposite side MN. But DA equals to Y, therefore MN must be also equal to Y. In the next step, I'll copy the right small triangle DGM again in a new page, and we'll continue to analyze this right small triangle DGM. Well, this is the right small triangle DGM that I got from the original drawing. In this small right triangle DGM, it is very easy to say that sinus theta equals to GM over DG. So sinus theta equals to GM is the missing side, so we'll leave it as it is, over DG equals to X, therefore we substitute DG in this equation by X. So in conclusion, we found out that according to equation 1, sinus theta equals to GM over X. Here we multiply this equation 1 by X, And finally we get that according to equation 1, Gm equals to x times sinus theta. Repeat again, according to equation 1, Gm equals to x times sinus theta. In the next step, I'll copy the right triangle ADE again in a new page and we will continue to analyze this right triangle ADE. So actually, this is right triangle ADE. This is coming from the original drawing. This right triangle ADE. It is very easy to see that sinus theta equals to dA over dE. So sinus theta equals to dA, that is y, over dE, that is 12. So in total, I'm trying to find out that according to equation 2, sinus theta equals to y over 12. This is according to equation 2. But according to equation 1, we have already found out that Gm equals to x times sinus theta. So we have here two equations with sinus theta. So here we can substitute this sinus theta in this equation 1, by y over 12 for this equation 2. We'll do it now, and we'll get that Gm equals to x times sinus theta, and sinus theta is y over 12. So in total, we actually found out that Gm equals to xy over 12. Gm equals to xy over 12. This is like Gm. This equals to x times y over 12. In the next step, we'll join points A and G together by a straight line. So what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and then at point G, that is the point on the quarter circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle. That is equal to R, according to our definition. So AG equals to R. So by joining points A and G together by a straight line, we created the right triangle AGN. So we copy this right triangle AGN in a new page, and we represent the Pythagoras theorem on this right triangle AGN. Here, by PT is a evaluation for Pythagoras theorem. The hypotenuse AG equals to R, on the right triangle AGN. we have already found out that sine AN equals to XR over 12. And what is the left of side GN of the right angle GN? GN equals to GM plus MN. That is to say, GN equals to GM, that is XY over 12 plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. So write it here. GN, this is at GN, this is equals to XY over 12 plus Y. So this is the right triangle AGN, that occurs from the original drawing. The hypotenuse AG equals to R, AN equals to XR over 12, and side GN in total equals to XY over 12 plus Y. Here, by PT is a relation from Pythagoras theorem. In this right triangle AGN, according to the Pythagoras theorem, AG square equals to AN square plus GN square. Again, in the right triangle GN, AG square equals to AN square plus GN square. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, the hypotenuse is AG, therefore the square of the hypotenuse AG is AG square, and it is equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is XR over 12 square. XR over 12 square equals to X square times R square over 12 square, that is 144. So in total, XR over 12 square equals to X square times R square plus 144 plus GN square. GN equals to XY over 12 plus Y, therefore GN square equals to XY over 12 plus Y square. So according to equation 1, we actually found out that R square equals to X square times R square over 144. Here we have this expression. Here we take Y as a common factor from this expression. So Y is taken as a common factor. So what is left from xy over 12 after we took from it Y as a common factor? What is left is actually x over 12 plus here what is left from Y after we took from it Y as a common factor? What is left it is actually 1 all squared. So actually, according to equation 1, we actually found out that R square equals to X square times R square over 144. And here we have this expression, the green color. Here we use the algebraic identity that states that A times B to the power of m equals to A to the power of m times B to the power of m. According to this algebraic identity, we get that y times x over 12 plus 1 square equals to y square times x over 12 plus 1 square. Okay? So if we found out that according to equation 1, R square equals to x square times R square over 144 plus y square. Here we will multiply 1 by 12 and then we divide it by 12 in order to overcome factor with x over 12. So in total in the numerator we'll have x plus 12 divided by 12 square. After we multiply 1 by 12, in the numerator we'll have x plus 12 divided by 12 square. So here we'll use here the algebraic identity that states that a over b to the power of m equals to a to the power of m over b to the power of m. According to this algebraic identity, we get that x plus 12 over 12 square equals to x plus 12 square over 12 square. Okay? So, according to equation 1, we actually found out that r square equals to x square times r square over 144 plus y square. Again, according to this algebraic identity, a over b to the power of m equals to a to the power of m over b to the power of m. We get that x plus 12 over 12 square equals to x plus 12 square over 12 square. Okay. The expression equals to x plus 12 square over 12 square. So we found out that according to equation 1, r square equals to r square times x square over 144 plus y square times x plus 12 square over 12 square. 12 square is 144. This is equation 1. In the next step, we will join points A and C together by a straight line. Those 2 points. Those are the points A and C. So what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point of the quarter circle itself. So this is exactly the definition for radius. Therefore, AC is the radius of this quarter circle, that is equal to R. So, in the next step, I will copy the right green triangle ABC in a new page, and we will implement the Pythagoras theorem on this right green triangle ABC. We just right now found out that the hypotenuse AC of the right green triangle ABC equals to R. We have already found out that side AB equals to Y, and side BC also equals to Y. Both those 2 sides are the sides of square ABCD, and we define one side of square ABCD is y, therefore all the four sides of square ABCD equals to y. So those two sides are the sides of square ABCD, both of them are equal to y. Here, by PT is abbreviation for Pythagoras theorem. So clearly, this is the right triangle ABC, the right green triangle ABC that est pas drawing. So according to the Pythagoras theorem, in this right triangle ABC, AC square, this will be equation 2, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it is equals to AB square. AB is Y, therefore AB square is Y square, plus BC square. BC is also Y, therefore BC square is Y square. So actually found out that according to equation 2, R square equals to Y square plus Y square is 2Y square. So according to equation 2, R square equals to 2Y square. While according to equation 1, we already found out that R square equals to R square times X square over 144 plus Y square times X plus 12 square over 144. So we have here two equations with R square. So now we can substitute R square in this equation 1 by 2Y square for this equation 2. We'll do it now. And we get that according to equation 1, R square is 2Y square. And it is equals to R square, it is 2Y square times X square over 144 plus Y square times X plus 12 square over 144. So here we divide this equation 1 by Y square. And you get that according to equation 1, this equation 1, 2Y square over Y square is 2. Here Y square will get cancelled, and we left only with 2X square over 144 plus, here Y square also will get cancelled, and we left only with X plus 12 square over 144. So here we'll multiply this equation 1 by 144. And we get that according to this equation 1, two times 144 is 288. And here we have 144 in the denominator will get cancelled, and we left only with 2x squared plus here 144 in the denominator will get cancelled because we multiply this equation by 144, and we left only with x plus 12 squared. So here we will open the brackets of this expression, and we get that according to this equation 1, 288 equals to 2x squared, and x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is 24x. So she found out that according to equation 1, 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. So here we subtract 288 from this equation 1. And we get that 288 minus 288 is 0. And it is equals to, in the other side of the equation, we have 3x squared plus 24x, and 144 minus 288 equals to minus 144. So here we divide this quadratic equation by 3, and we get that according to this equation 1, 0 over 3 is 0, 3x squared over 3 is x squared, plus 24x over 3 is 8x, and minus 144 over 3 is minus 48. So here, according to equation 1, 0 equals to x squared plus 8x minus 48. So write it down here. According to equation 1, x squared plus 8x minus 48 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0. So here the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So now we take those two coefficients a, b, and c that we found for our specific quadratic equation, and we put those three coefficients in this general formula for x in order to find out the value of x in our specific quadratic equation, this specific quadratic equation. So we'll do it now, and we get that here we have x equals to minus b. b in our specific quadratic equation is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a c. So minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. c is minus 48, and minus 4 times minus 48 is plus 192. So inside the root we have 64 plus 192 over 2a. a is 1, therefore 2a is 2 times 1, that is 2. So actually I found out that x equals to minus 8 plus minus, inside the root we have 64 plus 192, that is 256 divided by 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x, x equals to minus 12. But x can never be equal to minus 12. Why? Because of the fact that x is the length of this line segment GD, and x is a length, so x is a length, it must be a positive number. And therefore can never be equal to minus 12, that is a negative number. So we cancel this solution for x, and we take into account only the positive solution for x. And the positive solution for x is as follows. X equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So we shall find out that this is 97GD that is equal to x is equals to 4 units in its length. And that is the answer to the question. So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment GD is equal to x, according to what is given as the question. In addition, we know that this is line segment DE that equals to 12 units in its length, here DE equals to 12. This is angle GDC that is equals to theta, and this is also angle, this is angle EDC that is also equals to theta. Again, our mission is to find out the length of this line segment GD that is equal to x according to what is given as the question. So to find out the value of x. So first of all, we know that ABCD is a square, and we know that all the four angles inside any square are right angles. So those four angles of square ABCD, they are all right angles. In addition, we know that the opposite sides of a square are parallel to each other. So in square ABCD, side DC is parallel to the opposite side AB. So DC is parallel to AB. But here, AB is part of the straight line AE. Again, AB is part of the straight line AE, and AB is parallel to DC. And you know that if a part of a straight line is parallel to another straight line, then the straight line AE itself must be also parallel to DC. Therefore, AE must be also parallel to DC. AE is parallel to DC. Now we can implement here rule 15. Here, according to rule 15, alternating angles between parallel lines are equal to each other. So in the drawing we have line A, this is line A that is parallel to line B, and those two angles are defined as alternating angles, and they are located between the parallel lines A and B, and therefore they are equal to each other. That is to say, alpha equals to beta. So whenever you have two alternating angles that are located between two parallel lines, they must be equal to each other. In this case, because of the fact that line A is parallel to line B, and those two alternating angles, alpha and beta, are located between the parallel lines A and B, they are equal to each other. Alpha equals to beta. We can implement rule 15 in our drawing, because in our drawing we have line AE is parallel to line DC, here AE is parallel to DC, and those two alternating angles are located between the parallel lines AE and DC, and therefore they are equal to each other according to rule 15. That is to say, angle EDC, this is angle EDC, is equal to this angle, angle AED, according to rule 15. Again, because of the fact that those two alternating angles are located between the parallel lines DC and AE, they are equal to each other. But this is angle EDC that is equal to theta. So I can write here that angle EDC equals to theta. And from this equation, theta equals to angle EDC equals to angle AED. We will derive that angle AED is also equals to theta. So this is angle AED that is equals to theta. In the next step, we did a construction, that is to say, from point G, we draw perpendicular on AB. Again, from point G, we draw perpendicular on AB. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as M. Likewise, we define the intersection point of the perpendicular GN with side DC of the square as M. By doing this construction, we created here quadrilateral DMNA. This is quadrilateral DMNA. Inside this quadrilateral, you have 1, 2, 3 right angles. The sum of right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral DMNA to 360 degrees, this missing angle must be equal to 90 degrees in its size. So inside quadrilateral DMNA, we have 4 right angles. And we know that any quadrilateral that has 4 right angles must be a rectangle if not a square. So we relate to this quadrilateral DMNA that has 4 right angles as a rectangle. Okay. GN is perpendicular on AB, therefore GN is a perpendicular, it is absolutely a straight line. So if we focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to rule 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is a right angle plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the left side of GN at point M to 180 degrees, this missing angle must be equal to 90 degrees in its size. So if this angle equals to 90 degrees, therefore, triangle DGM is a right triangle. So this angle equals to 90 degrees. So I copy this triangle DGM in a new page and we analyze this right triangle, triangle DGM. So actually, this is the right triangle DGM as a copy from the original drawing. In this right triangle DGM, it is very easy to see that cosine theta equals to dm over dg. Again, cosine theta equals to dm over dg. dm is the missing side, so we leave it as it is over dg. dg is x, therefore we substitute dg by x. So in total, we found out that cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally found out that dm equals to x times cosine theta. This is according to equation 1. In the next step, we defined one side of this square ABCD as y. Therefore, AD equals to AB equals to BC equals to CD equals to y. And then we have here line segment AE. What is the definition of line segment AE on side AE? Side AE starts from point A, that is the center of the quarter circle, and then the point E, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle. That's equal, we define the radius of this quarter circle as R. Therefore, AE equals to R. In the next step, I copy this right triangle ADE. In the new page, we analyze this right triangle ADE. This is the right triangle ADE that I copied from the original drawing. The hypotenuse DE equals to 12 units in its length, according to what is given in the question. AD equals to y and A equals to R. In this right triangle ADE, cosine theta equals to AE over DE. So cosine theta equals to AE, that is R, over DE, that is 12. So in total, we found out that according to equation 2, cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. So we have in both those two equations cosine theta, and therefore we can substitute cosine theta in this equation 1 by r over 12 of this equation 2. We did it and actually found out that the dm equals to x times cosine theta. And cosine theta according to equation 2 is r over 12, and therefore in total we actually found out that dm equals to xr over 12. So here, this is side dm, that is equal to xr over 12. We have already found out that this polygonal dm and a is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle dm and a, side dm equals to the opposite side an. But dm equals to xr over 12, therefore an must be also equal to xr over 12. Likewise, according to the sum rule, in the sum rectangle dm and a, side dA must be equal to the opposite side mn. But dA equals to y, therefore mn must be also equal to y. In the next step, I copied again this right small target DGM in a new page, and we continue to analyze this right target DGM. This is right target DGM that I copied from the original drawing. In this right target DGM, it is very easy to see that sinus theta equals to GM over GD. Sinus theta equals to GM over DG. So GM is the missing side, so we leave this it is over DG. DG is x, so we substitute DG by x. So in total, we actually found out that according to equation 1, sinus theta equals to GM over x. So we multiply this equation 1 by x, and finally found out that according to equation 1, GM equals to x times sinus theta. In the next step, I copied again this right triangle ADE in a new page, and we continue to analyze this right triangle ADE. This is the right triangle ADE that I copied from the original drawing. In this right triangle ADE, it is very easy to see that sinus theta equals to dA over DE. Again, sinus theta equals to dA over DE. dA is y, DE is 12, so in total we should found out that sinus theta equals to y over 12. So according to equation 2, sinus theta equals to y over 12. But according to equation 1, we already found out that GM equals to x times sinus theta. So we have sinus theta in both equations, equation 1 and equation 2. Therefore, we can substitute sinus theta in this equation 1 by y over 12 from this equation 2. We did it and actually found out that GM equals to x times sinus theta, and sinus theta is y over 12. So in total, we actually found out that according to equation 1, GM equals to xy over 12. So here, this is the side GM that equals to xy over 12. In the next step, we join points A and G together by a straight line. So what is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle, that is equal to R. We have only found out that side AN equals to XR over 12, and finally side GN of the right triangle AGN equals to GM plus MN. That is to say, side GN in total equals to GM, that is XY over 12, plus MN over Y. So in total, GN equals to XY over 12 plus Y. Yeah, this is side GN is equal in total to XY over 12 plus Y. AN equals to XR over 12, and the opposite AG equals to R. Here by PT is a version from Pythagoras theorem. According to the Pythagoras theorem, in this right triangle AGN, AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is XR over 12 square. XR over 12 square equals to X square times R square over 12 square, that is 144. So in total, XR over 12 square equals to X square times R square over 144 plus GN square. GN is XY over 12 plus Y. Therefore, GN square is XY over 12 plus Y square. So according to equation 1, we actually found out that R square equals to X square times R square over 144. Then we focus on this green expression. Here we took Y as a current factor from this green expression. So y is taken out as a second factor. So what is left from x over 12 after you took from it y as a second factor? What is left is actually x over 12. And here, what is left from y after we took from it y as a second factor? What is left is it is actually 1 all squared. So according to equation 1, we actually found out that r squared equals to x squared times r squared over 144. And here we have y times x over 12 plus 1 squared. According to the algebraic identity that a times b to the power of m equals to a to the power of m times b to the power of m, we get that y times x plus 12 plus 1 squared will be equal to y squared plus x over 12 plus 1 squared. Okay? So according to equation 1, we actually found out that r squared equals to x squared times r squared over 144. And here we have plus y squared. Here we multiplied 1, in this expression we multiplied 1 by 12 and then we divided by 12 in order to have a common factor with x over 12. So after we multiplied 1 by 12, in total in the numerator we will have x plus 12 divided by 12 squared. So here we have, according to equation 1, r squared equals to x squared times r squared over 144 plus y squared. And here we have x plus 12 over 12 squared. And according to the algebraic identity that a over b to the power of m equals to a to the power of m over b to the power of m, we get that x plus 12 over 12 squared will be equal to x plus 12 squared over 12 squared. Again, x plus 12 over 12 squared, according to this algebraic identity, is equal to x plus 12 squared over 12 squared. The rest is not changed. We multiplied by y squared and plus x squared times r squared over 144, that is equal to r squared. So according to equation 1, we actually found out that r squared equals to x squared, r squared equals to r squared times x squared over 144, and here we have y squared times x plus 12 squared over 12 squared. 12 squared is 144. So according to equation 1, we actually found out that r squared equals to r squared times x squared over 144 plus y squared times x plus 12 squared over 144. In the next step, we join points A and C together by a straight line. So what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and then at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore AC is the radius of this quarter circle, that is equal to R. By joining points A and C together by a straight line, we created the green right triangle ABC. So copy this right triangle ABC in a new page, and we implemented the Pythagoras theorem of this right triangle ABC. This is the green right triangle ABC that I copied from the original drawing. We just now found out that the hypotenuse AC equals to R. We already found out that AB equals to BC equals to Y. Both those two sides. Also the sides of square ABCD. And we defined one side of square ABCD is Y, and therefore all the four sides of square ABCD equals to Y. That is to say, AB equals to BC equals to Y. So according to the Pythagoras theorem, in this right triangle ABC, AC squared equals to AB squared plus BC squared. AC is R, therefore AC squared is R squared, and it is equal to AB squared. AB is Y, therefore AB squared is Y squared, plus BC squared. BC is Y, therefore BC squared is Y squared. So in conclusion, according to equation 2, we actually found out that R squared equals to Y squared plus Y squared. Y squared plus Y squared is 2Y squared. So according to equation 2, we found out that R squared equals to 2Y squared. So copy equation 2 here again. According to equation 2, r squared equals to 2y squared, while according to equation 1, we have already found out that r squared equals to r squared times x squared over 144 plus y squared times x plus 12 squared over 144. So here we have two equations, equation 1 and equation 2, and we have r squared. Now, in both those two equations, we have r squared and r squared. So we can substitute r squared in this equation 1, and therefore we can substitute r squared in this equation 1 by 2y squared from this equation 2. We did it and we found out actually that according to this equation 1, r squared is 2y squared, and it's equals to r squared is 2y squared times x squared over 124 plus y squared times x plus 12 squared over 124. So here we divided this equation 1 by y squared, and finally found out that according to equation 1, 2y squared over y squared is 2. Here y squared will get cancelled, and we left only with 2x squared over 124. Here y squared also will get cancelled, and we left only with x plus 12 squared over 124. Here we multiply this equation 1 by 144, and finally found out that according to this equation 1, 2 times 144 equals to 288. Here 144 in the denominator will get cancelled because we multiply the equation by 144, and we left only with 2x squared. Here 144 in the denominator will also get cancelled, and we left only with x plus 12 squared. So according to this equation 1, we actually found out that 288 equals to 2x squared plus x plus 12 squared. Here we open the brackets of this expression, and finally found out that according to this equation 1, 288 equals to 2x squared plus x plus 12 squared. X plus 12 squared, according to the algebraic identity that a plus b squared equals to a squared plus b squared plus 2 times ab will be equal to x squared plus 12 squared, that is 124, plus 2 times x times 12, that is 24x. So according to equation 1, we actually found out that 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 124. Here we subtract the 288 from this equation 1, and finally found out that 288 minus 288 is 0. In the other side of the equation we have 3x squared plus 24x, and 124 minus 288 equals to minus 144. So here we divided this quadratic equation by 3, and finally found out that according to this equation 1, 0 over 3 is 0, 3x squared over 3 is x squared, 24x over 3 is 8x, and minus 144 over 3 is minus 48. So we actually found out that according to equation 1, x squared plus 8x minus 48 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So we have to put those values of a, b, and c that we found for our specific quadratic equation in this general formula for x, in order to find out the values of x for our specific quadratic equation, this specific quadratic equation. We did it and found out actually that x equals to minus b. B is 8, therefore minus b is minus 8, plus minus square root of b squared. B is 8, therefore b squared is 8 squared, that is 64, minus 4 times a, c. So minus 4 times a is 1, so minus 4 times 1 is minus 4 times c. Minus 4 times 1 is 48, c is 48, so minus 4 times 1 is 48 equals to plus 192. So in total inside the root we have 64 plus 192 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So x equals to minus 8 plus minus, and 64 plus 192 is 256, so inside the root we left only with 256 divided by 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we will have two solutions. Here we will have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x equals to minus 12. But x can never be equal to minus 12. Why? Because of the fact that x is the length of this line segment GD. So x as a length, it can never be a negative number. It must be a positive number. And therefore the negative solution for x is in correct solution and cancel this negative solution, and we focus on the positive solution for x. And the positive solution for x is as follows: x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So in conclusion, we found out that the length of this line 7GD that is equal to x is equal to 4 units. Okay, thank you very much.